So in this video, we're going to be talking about the exponential rules and how we can simplify expressions using those rules of exponents. So let's go ahead and get started. There are 6 of them, and you should take notes as we go. But I'm going to start each one with a little question for you to contemplate on your own. See if you can figure out what is 5 to the 0 on your own. Well, hopefully you've made a guess as to what that is. 5 to the 0 is actually 1. Why is it 1? Well, it follows some patterns. If we look at some simple patterns here, for example, we can take, let's say we go with the 2's. Let's say we take 2 to the 4th, and then 2 to the 3rd, 2 to the 2nd, and 2 to the 1st. We know that 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 3rd is 8, and 2 to the 4th is 16, and it just keeps doubling as it goes up. We could also think of it getting half as big as we go down. Well, if this pattern continues, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, the next one would be 2 to the 0. Well, if that pattern continues on the right-hand side, half of 16 is 8, half of 8 is 4, half of 4 is 2, half of 2 is 1. And so we can see that 2 to the 0 is 1. This works with any type of base. For example, we can have a base of 10 and go 10 to the 4th, and 10 to the 3rd, and 10 to the 2nd, and 10 to the 1st. And 10 to the 1st we know is 10. 10 to the 2nd we know is 100. It's 10 times 10. 10 to the 3rd is 1,000. And 10 to the 4th is 10,000. Well, if we continue this pattern, going down 4, 3, 2, 1, 10 to the 0, I'm dividing this number by 10. A tenth of 10,000 is 1,000. A tenth of 1,000 is 100. A tenth of 100 is 10. And a tenth of 10 is just 1. And so we can see here again, 10 to the 0 is 1. So the 0 exponent rule says that anything to the 0 power is always going to be 1. The exception here is that if x is 0. If we have 0 to the 0th power, that's just simply going to be 0. But anything to the 0 power is 1. That's the 0 exponent rule. That's the first one. Let's take a look at the next one, the negative exponent rule. So I want you to try to figure out what is 5 to the negative 2nd power, and then what is 1 over 4 to the negative 3rd power. Go ahead and pause the video, try those on your own, and then restart the video. Well, hopefully you were able to get this. 5 to the negative 2nd is 1 over 25. 1 over 4 to the negative 3rd, well, that's simply 64. So how did we get that? Well, if we look at the same patterns that we had up here before, we started with 2 to the 4th, and then 2 to the 3rd, and 2 to the 2nd, and 2 to the 1st, and 2 to the 0. And we said this was 16, and this was 8, and this was 4, and this was 2, and this is 1. And you can see these numbers get half as big as we go down the row here. Well, this pattern can continue. 2 to the negative 1st, 2 to the negative 2nd, 2 to the negative 3rd, and so on. Well, if we continue cutting this in half, half of 1 is a half. Half of a half is a 4th. Half of a 4th is an 8th. Now there's a pattern here between 2 to the 3rd and 2 to the negative 3rd. You see 2 to the 3rd is 8. 2 to the negative 3rd is 1 over 8. Same thing, 2 to the 2nd is 4. 2 to the negative 2nd is 1 over 4. So if we were asked what is 2 to the negative 4th, well, that's the same thing as 1 over whatever 2 to the positive 4th is. So in other words, whenever we have a negative exponent, we can make it a positive exponent by putting it on the bottom. And so that's what we did here with number 2. 5 to the negative 2nd is the same thing as 1 over 5 to the positive 2nd, which is 1 over 25. It works the other way too. If I have a negative exponent that's on the bottom, I can make it a positive exponent by putting it on the top. So 1 over 4 to the negative 3rd is the same thing as 4 to the positive 3rd if it's on top. And 4 to the positive 3rd is 64. And so what is the negative exponent rule? The negative exponent rule simply says that, some of this stuff, simply says that if we have b to the negative nth, that's the same thing as 1 over b to the positive nth. And then if this is a positive, we can make this negative, so it works in both directions. So there's 2 rules. We have the 0 exponent rule and the negative exponent rule. Let's move on. The product rule. This one might be the easiest one. X to the 4th times x to the 3rd. Pause the video and see if you can figure out what that is. If you had x to the 7th, that is correct. And here's how this works. X to the 4th is simply x times x times x times x. We have 4 of them. Times x to the 3rd, which is x times x times x. Well, if I put all these together and I multiply them all together, I have 7 x's. That's the same thing as x to the 7th. So I have these 4 plus these 3. And so what I'm going to do is, whenever I have like bases, I add the exponents. And that is the product rule. The product rule says if I have x to the mth times x to the nth, I simply can add the two exponents together. Let's move on. Take a look at number 5. The quotient rule is very similar to the product rule. Maybe see if you can figure out what this one is on your own, and then restart the video. If you had that this is x to the 2nd, you are correct. A couple ways we can think about this one. X to the 5th, that's 1, 2, 3, 4, 5 x's on top, and 1, 2, 3 x's on the bottom. Well, these 3 x's can wipe out these 3 x's, and I have 2 left over. Another way to think about this is I can keep the x to the 5th there, but because this x to the positive 3rd is on the bottom, I can move it to the top and make it x to the negative 3rd. And then I could just add the exponents. 5 plus a negative 3 is x to the 2nd. So there's 2 ways to think about that. But the quotient rule simply says this, that if I have x to the mth on top and x to the nth on the bottom, I can simply subtract the 2 exponents. 5 minus 3 is 2. And that's the quotient rule. Let's move on. Take a look at this one. What is n squared, the whole thing, to the 4th power? This is sometimes called the power to a power rule, or simply the power rule. And if you guessed correctly, if you had n to the 8th, you are correct. And here's how this works. N squared to the 4th means we have 4 factors, and in those factors, they're all n squared. So if each one of these is n squared, then I have n times n here, n times n here, and I have n times n 4 times, which is a total of 8 n's, which is n to the 8th. Good way of thinking about that is I'm just multiplying those exponents together. So the power rule looks like this. X to the mth to the nth power is simply x to the m times nth power, and that is the power rule. So there's 5 rules. The last one is the expanded power rule, and it's kind of like using the distributive property. Let's go ahead and see if you can figure out what 7 and 8 are, and then we'll talk about them and clarify what the expanded power rule is. So if you had, for number 7, 3n squared m to the negative 3rd to the 4th, that whole thing would simplify to, let's see, 81, and then it's going to be n to the 8th over m to the 12th would be our final answer. Now there's a couple of steps that we can get to from there, and then the number 8, if you had this as your final answer, you would be correct. This is going to be 9 x to the 6th y to the 4th over 16 would be your final answer. So here's how this works. We're going to have to take this 4 here and distribute it to all of the factors inside the parentheses. So 3 to the 4th, that's 3 times 3 times 3 times 3, that's the 81. N squared to the 4th, if I use the power rule there, that's n to the 8th. And then m to the negative 3rd to the 4th, that's m to the negative 12th. But I have a negative exponent, so if I use the negative exponent, or the negative power rule, the negative exponent rule, this is going to have to be moved to the bottom. And I would end up with 81 n to the 8th over positive, or over m to the positive 12th, which is what I have here. Same concept for number 8. I'm going to have to take this 2 and apply it to every single factor, the 3, the x to the 3rd, the 4, and the y to the negative 2nd. So 3 to the 3rd is simply the 9. X to the 3rd squared, I multiply those using the power rule, that's x to the 6th. 4 squared is 16. And then y to the negative 2nd to the 2nd is y to the negative 4th, but that's a negative exponent. If I want this to be a positive exponent, I'm going to have to move that whole term up on top. And that's how I would get the y to the fourth on top. And it's 9x to the 6th, y to the fourth, over 16. And so the expanded power rule is two different forms. Could start like this. Xy to the nth power means you have to take the x to the nth and the y to the nth. Or if it's a fraction, I'm going to have to apply that n to everything on top and everything on the bottom, as you see here. So that's what our topic is for today. Hopefully you've taken good notes over this, and we will see you tomorrow in class.